I would like to help you use the conditions and properties of these quadrilaterals to build a better GeoGebra file for these 6 figures. So if you've already received a score if you had already received a score by Friday, it indicates that your figures held the conditions that were necessary for each particular figure. If they had right angles, those right angles stayed right angles. If they had parallel sides, the parallel sides stayed in cases where I dragged them around. So go ahead and improve that file by changing colors, adding things with the decoration tool, which I'll show you how to do in the video, or make some other improvements to the file. So spend some time improving the quality of the file if you were one of the few students who already had a score on Friday morning. If not, everybody has received a score by now for process for this, if you submitted a file. But the score you'll receive for Monday is for improving that file. So this is an editing and revising assignment. Still got a pretty heavy process score, so it's important. You're going to want to get this done well. There will be a performance score later in the week that improves this file even more. So for now, let me show you how you can use the conditions that exist. So let's find, let's go to the Math is Fun website. For the properties of quadrilaterals. The last website I used had some typos in it that I didn't really like. And that was Math is Cool or Cool Math. So any 4-sided shape is a quadrilateral. Yeah, we know that. We're not going to bother to show that figure, but we're going to make these other 6. Now this is interesting. The diagonals of this regular quadrilateral are just not that interesting, but the details for the diagonals of this square are important. We have perpendicular diagonals here, so maybe creating one right triangle that is a 45, 45, 90, so that it remains an isosceles right triangle, and then rotating it 90 degrees, another 90, and another 90. Maybe that's a good way to create a square, by using the polygon tool all the way around a figure that you make like that. And let's analyze the properties of some other types of quadrilaterals. Opposite sides are parallel, and a rectangle is a 4-sided shape where every angle is a right angle. Well, so if I create a right triangle on perpendicular lines, and then I don't want to reflect it, I'll get a kite if I reflect it, but what if I rotate it through the midpoint of the long side? I'll get a rectangle that has to remain a transformation of a right triangle. So my right angles will remain right angles. So what are the conditions of a rhombus? Well, the diagonals of a rhombus are perpendicular. So that's one way to start. If I have a pair of perpendicular sides, and I know that these segments are even, couldn't I build one right triangle that was not isosceles and reflect that once, twice, 3 times, and then build a polygon around that using the polygon tool? Same thing with a square. What do I have to have? The diagonals of a square are going to bisect each other, and they're going to be perpendicular, because a square has the properties of a rhombus and the properties of a rectangle. The diagonals of a rectangle already bisect each other, but they're only perpendicular when that rectangle is also a square. We know how to build a parallelogram. You take one triangle, add a midpoint to one of its sides, and rotate the triangle 180 degrees around that midpoint. So using transformations, you should be able to build any of these figures. Now the trapezoids are really interesting. All I need really is a pair of parallel lines. And what if I had a perpendicular line right here? I could build a right trapezoid, and that could easily be reflected over the right angle side to make an isosceles trapezoid. So I'd like you to use transformations to build all of these figures. And you might need to know something more about the properties of the diagonals or the legs in the case of an isosceles trapezoid. Here's a great photograph, or a great image. This isosceles trapezoid right here clearly shows you how to cut this in half to reflect over a vertical line and create the isosceles trapezoid. So, don't be afraid to use what you know about these figures and what you know about how to use GeoGebra to get yourself the tools you need to use transformations. So I now have a line where the x-axis was, and I'm going to use the perpendicular line tool. Perpendicular line, I'm putting a point on the y-axis, and I want a perpendicular line through the x-axis. So let's put a point at 0,5. Perpendicular through C, perpendicular to the x-axis. And I don't really need all of these intervals marked. So I'm going to turn those off. And what can I do? What if I had just a simple little triangle built on these perpendicular lines? What if I made this one? It's not an isosceles, there's nothing really special about it, except that it's got a right angle at A. And I can do a lot with that particular triangle. What if I make that rotation around A that we talked about? 90. I think I want to go counterclockwise, but I want to take a look. Nope, not counterclockwise. And maybe it's not A I want to go work around. What if I had a segment here from A to E and I used the midpoint or reflection? I want you to analyze what the figure looks like to begin with, and then play around with the transformations. This undo button is pretty handy right here. We can undo anything you do with that, just like a Word document. Well, I sure could get a rhombus if I keep reflecting. And I can use the decoration tool. I would like segment A sub 1, so I'm going to go directly to it over here in the menu on the left. I want to go to its properties, and I want to find that decoration tool to mark this segment with one mark. Now I didn't get the mark I expected. A1, so let's find out why not. Object properties, decorate it. What's going on in basic? Show label, show trace. Yeah, I got it that time. Oh, I see, it's down here. Got it. So let's keep going down. Segment A double prime. This is the segment. I would like my properties, my decoration tool, my single mark. So those three are marked congruent, and a triple prime. Properties, decoration, one mark. Apparently that's already marked. So it's this one I need. Segment A double prime. Object properties. I didn't get my decoration tool, so I'm going to go over here to segment A double prime, properties, didn't get it that time either. So I'm just gonna keep clicking until I get what I'm after. I'm gonna go to the regular arrow tool. There's my decoration tool. And I have now marked the properties of this rhombus. We could also add, I'm going to turn off some of these figures. I would like E triple prime to turn off, E double prime to turn off. I would like the D's to turn off. O's can go off. I guess that's this guy. I don't really need a label on E or on A. Now, on my version of this software, I haven't actually figured out why these polygon labels stay on. So I'm just going to try to go over here and see if Polygon 1's label can go off. Nope. Huh. So I'm getting the labels on more than once, which is not at all what I'm after. I'm going to try one more, see what happens. There we go. So I've still got this label on F. Where's that coming from? This guy, F. Let's get rid of your label. There we go. So great rhombus. I'm happy with that rhombus, and I can move this figure around and it stays a rhombus. Actually, just turning off the points stops me from moving it around. I can turn this figure off, and I can add a definition box and talk about the rhombus. And put that anywhere I want. I would like a definition from you, a correct definition for rhombus in here also. So we now know how to use the decoration tool. We know how to create a pair of lines. Let's go ahead and make a line parallel through B that's parallel to this guy. And let's now make a perpendicular line through B, perpendicular to this guy. And maybe if I had a segment of a given length, so segment tool, so I can start off with any segment. And let's get exactly that same segment by rotating this segment. I'm going to turn off the line because I don't want to rotate the whole line. I want to rotate this segment around point B. I want to go 90 degrees, and I would rather go clockwise. And now if I turn these 3 points into a polygon, I'm going to have an isosceles right triangle. Well, that sure is going to make a square that can't be anything else but a square if I rotate it correctly or reflect it correctly. So let's reflect this figure around this line, this figure around this line, and this figure around this line. And is there any way that this original 45, 45, 90 didn't create a 90-degree angle here when those two 45s came together, and a 90-degree angle here when these two 45s came together, and a 90-degree angle here when these two 45s came together? In order to keep this figure together, I have to wrap it in the polygon tool so that when I grab it and drag it around, it remains a square. And it's a square that's fixed on these 2 points. I would like one more figure in this document, and that's made with right triangles